Diamonds are delicate enough to dazzle in jewellery and tough enough to withstand heavy industrial use. But lately, it's their precise quantum properties that have unlocked a host of new applications. A pure diamond is made of a repeating crystal of carbon atoms, but diamonds really shine when they have impurities in them, and physicists are particularly interested in one impurity. That's when a carbon atom is replaced with a nitrogen and a neighbouring carbon atom is missing. Together, the nitrogen and the vacancy act like a single entity, an NV center. This center has a physical property called spin. The NV spin is like two tiny compass needles. They either both point up, giving a spin of 1, both down, spin -1, or when one is up and one is down, spin 0. And it's this spin that makes NV centers so handy to physicists. If you shine a green laser on an NV center, it re-emits light at a lower red frequency. But an NV center emits more light when it's in the 0 spin state than when its needles are both pointing up or down. And researchers can use this to check what the spin is up to. A microwave at just the right frequency can flick an NV center from 0 spin to up or down, a change that causes the red light to dim. Scientists can use this for all sorts of applications, like diagnosing disease. Tiny diamonds can be attached to a particular virus molecule. The researchers use microwaves to brighten and dim the light the diamonds give off. This helps the diamonds stand out from the crowd of light pollution in a biological sample. Spotting a diamond means that the virus is present and the disease is detected. NV centers can also transform diamonds into incredibly sensitive magnetic field detectors. The energy of the NV is now different when its spin is aligned with the magnetic field rather than against it. This means that the NV center needs one frequency microwave to flick its spin from 0 to up, and another to flick from 0 to down. Measuring the difference between the microwaves reveals the strength of the magnetic field. The NV center's sensitive compass can be used to accurately measure the natural magnetic field where you are. Cross-reference that measurement with a detailed map of the Earth's magnetic field, and you can work out where on Earth you are without GPS satellites. Or an NV center could measure the minute magnetic field variations caused by brain activity, shrinking down today's bulky medical equipment. To pull off all these tricks, physicists need to have the right diamonds, which are extremely hard to come by in nature. So engineers are getting better and better at making diamonds. These are grown from a plasma made of carbon atoms. Nitrogen atoms can be added to the mix, and carbon atoms can be shot out with an electron beam to create vacancies. These custom diamonds with their powerful NV centers could even help physicists build the quantum computers of tomorrow. So the future is certainly looking pretty bright for diamond science.